Hey mathematicians, here are your notes for 3.3, Graphing Systems of Inequalities. So to solve a system of inequalities, we have to graph the inequalities on the same coordinate plane. The solution set is represented by the intersection of the graphs. When we were working with equations, you remember that this was just a single point. A single ordered pair was our solution. However, when we're doing inequalities, you can see that the shaded area of the two graphs is now our solution. So, when we start this off, which system of inequalities matches the graph shown at the right, we need to find a point that works on our graph and then test that point in the options in order to figure out which one is correct. I don't want to go to all the work of graphing all of these. They're all very similar. So the fastest way is to just test a point. I notice right off the bat my favorite point in the world, the origin, is in my solution set. So I'm going to go ahead and take that origin point over to my four options and test it. So right away when I plug it in here, 0 minus 0 is not less than -2, negative numbers. So that's why I've already crossed A off. Let's go, I guess we can go to B here next. We go to 0 minus 0 greater than -2. It works for that one, perfect. 0 minus 0 is less than 2, it works for that one. So because it works for that, B is my correct answer. I don't even have to test any further, but I will just to be thorough. 0 plus 0, still not less than -2. This one I can already cross off. 0 minus 0, still not greater than -2, yes, and less than -2. However, the reason that we know it's not the second one is because when we go back and check our signs, we'll notice that this one has the or equal to, meaning this line is going to be solid, while the lower one has just the less than symbol, not the or equal to, meaning that lower one's going to be dashed. I should have paused, I should have checked my other options because these two are very similar. I'll admit I knew the answer already and I got ahead of myself. But that is how we know the difference when two options work. We have to check those signs. They are the giveaway for what the difference between those two very similar options actually is. All right, I'll try not to get too excited again. I know I jumped on that one, but that's okay. Next up, how would you draw an absolute value inequality containing only one variable on the coordinate plane? Well, much like we did before with absolute values, let's solve this. Let's see what our options for x are. Remember, when we have the absolute value, we have the positive version, x less than 3, but we also have the negative version, negative x less than 3, because either version could go in there. Then, of course, when we solve this, we get positive x is greater than -3. Now we can graph these as if they were equal signs equations. So x less than 3, that is going to be a dashed line at x equals 3. I put little arrows to indicate, instead of shading right away and seeing where the shading overlaps, I just do arrows. If you want to shade things in different colors and then see where they overlap and shade that area darker, that is totally okay too. This is just my preferred method. X greater than -3. Okay, I'm going to go to -3. It's also a dashed line. Greater than goes to the right. I notice the area where my arrows point together is everywhere in the middle here. And that is what I shade. Just like that. Let's see another one here. The absolute value of y plus 1 is greater than or equal to 5. Obviously, we have the positive, y plus 1 greater than or equal to 5. There's one of ours. But we also have the negative version, negative y plus 1 greater than 5. I'm going to throw that negative in there right away. Now let's solve, move that 1 over. We get negative y greater than 6. Flip that sign when we multiply or divide by a negative. Don't forget that. That is very, very important. That will mess up your problem if you don't. So I've got my one there, and then of course let's solve the top one here. Move that one over. So I've got y greater than or equal to 4, y less than or equal to -6. These are both going to be solid lines. So Let's go up to +4 right there. Solid line. Okay, and then it is greater than -4, so I'm going to throw my arrows in the upward direction. Y is less than or equal to -6, down to 6, still that solid line. Less than means down. Notice my arrows don't intersect here, that is okay. I just have two separate areas to shade on my graph. So big things when you're working with these absolute values and these inequalities. Make sure you have your two different answers. Absolute values always come with two solutions there. And then, of course, make sure you're checking your sign to know first whether your whether your line is going to be solid or dashed. This is why I love doing this in pencil. I do it in pen for my videos so that you can see, but pencil is a lot easier to correct on tests for you if you make a mistake. So, just a suggestion. Solve the system of inequalities by graphing. Let's keep going with it. Notice this is a linear equation, same thing here. So we're just going to graph those lines to start off with. This is a solid line, so I'm going to go to -1. I have a slope of 2. Grab my straight edge here. Solid line. Nice. It says that y is less than or equal, so I'm going to check the origin. 0 is less than -1. That is, let me double check that. 0 is less than or equal to -1. That is not the case, so I'm going to draw my arrows going this way. Always good to double check yourself. Next line, I notice it is dashed because there is no line underneath my inequality. Go up, actually I'll do this in a different color so we can differentiate our lines here. First one's in purple, second one's in green. Okay, there's my origin, go up 2, 1/3, so up 1 over 3, down 1, back 3. That's a dashed line, but I'm still going to use my straight edge. We still like to be precise. Okay, same thing, let's test the origin. Let's see if it's on this side or this side. 0 is greater than +2. No, not the case. So I am going to say that every value on the upper side of this line works. Check to see where those arrows point together. It's in this itty bitty little space up here. It would go on forever in this direction too, but I'm obviously already off the graph. So there we have it. Let's jump to the back now. Solve each system of inequalities by graphing. We're getting good at this. I want you to take a minute, pause the video, see if you can go ahead and try those two examples. Notice the second one has 2 here, but you've got an absolute value. How does that change your answer? All right, come on back when you've had a minute to try them. All right, let's do these together. Hopefully you had enough time to pause the video, try them on your own. I personally don't like the standard form here. I'm going to go ahead and put them in my y equals form. I think they're a little easier to see. I move that x over. I divide by a -1, so it flips the sign, and this becomes y is greater than or equal to x minus 2. Same thing on the bottom. I'm going to move that x over and divide everything by 2, so I get y alone. I get y is greater than or equal to -1/2 x plus 1/2. Just like that. All right, and now let's graph them. Go down to -2. They're both solid lines. I like when they're solid lines. A little bit easier to draw in my opinion because I have my straight edge here. Let's check that origin. 0 is greater than or equal to -2. That is a true statement, so I'm going to point my arrows towards the origin, towards the side that works. All right, y greater than or equal to -1/2, so we're going to go up to 1/2, and then it's down 1 over 2. That's kind of a hard one. Down 1 over 2, just like that. Again, still a solid line. Close enough. The origin is now on this side. Let's check anyway. 0 is greater than or equal to 1/2. That is not the case, so our arrows are going to point up, up, and away from the origin. Let's check to see where those arrows intersect. Right in this area in here. So that is what I'm going to shade. All right. Next one, x greater than 2. Right off the bat, works for me. I'm gonna do that one, throw it on there. I'm gonna go here, it is a dashed line. I'm gonna be real careful about that. Greater than 2, we already know it's gonna go to the right. We don't have to check the origin because 0 is not greater than 2. That one's pretty easy. And now let's work with that absolute value. We've got the positive version, y minus 1 is less than or equal to 3. I solve, I get y is less than or equal to 4. Simple. But let's do that negative version as well. Negative y minus 1 would be negative y plus 1. I just distributed a negative into both of those. Remember, absolute value can give us the positive or the negative. Less than or equal to 3. Move the 1 over. We get 2. Flip that sign when we divide by a negative, and we get y is greater than or equal to negative 2. Now let's throw those on our graph. Y is less than 4. That one is a solid line. Solid horizontal line at 4. Y is less than, meaning we're going down. Y is greater than negative 2. There's my origin. That is also a solid line. Greater than means I'm going up. Notice I now have 3 areas that I have to find the intersection of. My arrows are going this way, so I'm going to be on this half of the line, and of course these arrows point together, which means I'm going to shade in this area right here, just like that. So you can do this with quite a few equations. As you can see, 2 is probably pretty simple, 3 is a little bit tricky depending on your equations. Let's take it up one more notch. Classy catering needs at least 15 food servers and 5 bussers to cater a large party. But in order to make a profit, they can have no more than 34 food servers and 7 bussers working at an event. Write and graph a system of inequalities that represents this information. Well, as we do, let's go ahead and assign some variables. X is going to be our food servers. Y is going to be our bussers. And notice we had a max and a min for each of these. So let's just go ahead and write our inequalities. It said they need at least 15 food servers. So X has to be greater than or equal to 15. However, they also said they can have no more than 34 food servers. So X had to be less than or equal to 34. Now, we can keep those separate. You could also combine them and say that X has to be greater than or equal to 15 and less than or equal to 34. I don't have a preference on how you write it. But let's jump to bussers as well. It says it needs 5 bussers to cater a large party, but no more than 7. Same thing. Y has to be greater than or equal to 5, and Y has to be less than or equal to 7. When we throw that into one equality, it looks like this. Now, how do we graph these two inequalities? Well, let's go ahead and put food servers on our X because they're what we assigned X. And then let's put bussers on our Y. And we'll do 15 to 34. Let's go up in terms of tens. 10, 20, 30, 40. 5 to 7, we can go up in terms of 2, 2, 4, 6, 8. All right, so X has to be greater than 15 but less than 34. Both solid lines, so I'm going to go ahead and say right here is 15. Has to be greater than 15. Less than 34. 35 is about right there. Let's go just a little bit to the left. Still a solid line. Has to go less than 34. Next up is busters. It has to be greater than 5. 5's about right there, still a solid line. Greater than 5, less than 7. Here's my 7. I know it has to be less than that. We now have 4 intersections that we need to work with. So it has to be between these two and between these two. So the area of servers we could have is right in the middle. So now you've seen it with 2, 3, and 4 different inequalities. At this point, you should be able to do your homework. If you have any questions, don't hesitate to let me know.